Today we're going to be looking at ratios. Our goal is to interpret and use ratios in different contexts. Today we're going to visualize part-to-part ratios using pictures and visualizations, as well as identifying part-to-total ratios using visualizations and drawings. So what is a ratio? Well, a ratio uses division to compare two numbers. There are three ways to write a ratio of two numbers. Make sure you're writing down the definition. And then I'll give you the three different ways we're going to write ratios. So when we write a ratio, we can use words, numbers, and algebra. And there's three different ways we use numbers to represent ratios. Wins to losses, if I had 18 to 13, I can write it 18 to 13. We can also have wins to losses, 18 over 13 as a fraction. We can write ratios as fractions, as well as wins to losses as a colon, 18 to 13. Now in all of these cases, you would say wins to losses or 18 to 13. There's just three different ways we can write them. Make sure you're having a copy of this diagram in your notes. It'll definitely help you down the road. Some common mistakes are thinking a ratio describes only one situation. And the example that can pop into my mind is one that I'm going to give you in the next page, which is 2 eggs for 3 cups of flour. Now, of course, you can double, triple a recipe, so you can have a ratio that's 2 to 3 written as 4 to 6, or even 6 to 9. Another common mistake is students will sometimes invert the order of a ratio. It's important to see, of course, if it's wins to losses, that we don't write them as losses to wins, because these are different ratios. So watch out for those common mistakes. So what does it mean to use a ratio? Well, let's look at an example. Cupcakes. A recipe calls for 2 eggs for every 3 cups of flour. So our ratio is 2 eggs for 3 cups of flour. So it is important that when I write my ratio, I have eggs first, which is 2, and 3 cups of flour, to 3. But I can write it in more than one way. I can make more than one recipe batch of cupcakes. For example, if I double the recipe, I need 4 eggs and 6 cups of flour. And likewise, if I tripled the recipe, I would need 6 eggs and 9 cups of flour. And of course, you might be able to relate ratios to fractions. When we double a fraction, triple a fraction, we reduce it into simplest form, we get the same ratio or the same fraction. Ratios are similar to that, only when we have a ratio. If the ratio was the opposite, and instead of being 2 eggs for 3 cups of flour, if we said 3 cups of flour to 2 eggs, we would actually write it as an improper fraction and leave it at that, 3 to 2. But in this case, of course, it's a proper fraction. Let's try another example. Roller coaster. You wait in line for 90 minutes to ride a roller coaster. If the ride lasts for 2 minutes, what is the ratio of time spent in line to time spent on the ride? So, a good idea, of course, is to make sure you're checking the order. So, time in line to time spent on the ride. So we know that in this case, the time we waited in line comes first. We know that that number is 90 minutes. So I'm going to choose to write it as a fraction. So we have 90 minutes, and the ride lasted for 2 minutes. So my ratio is 90 to 2. I can simplify that ratio and say that, well, for every minute of my ride, I had to wait in line for 45 minutes. So 45 to 1, and you do have to have that 1. Again, I could have written it as 45 to 1 or 45 to 1, and same with the 90 to 2. 90 to 2. All of those are correct ways of writing the ratio 90 to 2 or 45 to 1. I'm sure we've all been there with roller coasters. Let's try another example. Cookies. For a birthday party, Rosemary purchased 36 cookies. If there were 13 children at the party, what is the ratio of cookies to children? Now in this case, we have cookies first, children second. So I'm going to manipulate that order. Well, we know that there were 36 cookies and 13 children. So now I have my 36 cookies, and I know that there are 13 children. Sorry, I realized that should have been 26 cookies for 13 children. So I have 26 cookies here. So for every child, I can see that each child would get 2 cookies. So when I have a ratio of 26 to 13, it is the same as a ratio of 2 to 1. And again, I can write it any one of the 3 ways that we discussed previously. So I hope you can see how ratios work. Let's try one final example. According to the table, who has the greater ratio of rock albums to pop albums? So we need to now compare ratios. Well, we have George and Abigail. So I'm going to put a G for George. So George has 9 rock and 16 hip-hop, whereas Abigail has 28 rock and 40 hip-hop. Now, a common mistake is students will say, well, 28 and 40 is bigger, so she has the greater amount. She may have more albums, but we don't know yet if she has a greater ratio. What we need to do is compare them. And we remember ways that we can compare fractions. We can reduce them, find a common denominator, or some of the easiest ways that I like to do is transfer them to a decimal. So 9 divided by 16. And then we have 28 divided by 40. And in reality, I would actually reduce these first and then compare them. But hopefully you realize that I'm going to get a 0 here, 90 5 times. So this is 0.5, and I'm going to actually stop there. So I have 40, and it's going into 280, because it can't go into 28 7 times. So I can actually stop there, because 77 times 4 is 280. And even though I'm not done here, this is going to be a bigger decimal, I can then see that Abigail has a greater ratio of rock to pop. Oh, to hip hop. So Layla asked who has a greater ratio of pop to hip hop. Now, if we compare the original, which is rock to pop albums, we have 9 to 24 for George. So we have 9 to 24, and then Abigail would have 28 to 70. And again, we can compare these fractions. And again, I can use division, or I can actually use the lazy way that we've described in previous tutorials to compare the fractions. So we have 9 times 70, which of course 9 times 7 is 63, add the 0. And then we have 24 times 28, which is going to give us 672. too. So we can see that Abigail also has the greater ratio of rock albums to pop albums in this scenario. Now it's your turn. Write the ratio in simplest form. So we have 7 to 14, we have 18 to 63, we have 20 to 35, and 30 to 9. I've written them in different ways for you. I want you to now write them in simplest form. If they're already in simplest form, rewrite them. And I want you to try one problem on your own. A bag has 20 blue marbles and 7 red marbles. Write the ratio of red marbles to the total marbles. So I want you to do some thinking for this and come ready to discuss this next time for your number talks. In this lesson, we've learned how to compare ratios. We've also learned how to use ratios to help us visualize different scenarios. We used ratios in real-world contexts. Now I hope you're ready to use ratios all over. Ratios are everywhere. They're in statistics, they're in betting, they're in sports all the time. So we see ratios a lot, but we don't always identify them as ratios. Go ahead and try to observe ratios in the real world all around you. If you happen to watch a game, look to see where they're using ratios in a baseball game or a soccer game or any other kind of game. Another great job today, and good luck.